A new scientific paper's just exposed a chilling discovery about the interstellar visitor 3 Atlas. At precisely 2.1 astronomical units from our Sun, 3I Atlas started venting hydrogen cyanide, an invisible deadly gas. Scientists call it outgassing, but here's what they won't tell you. Comets don't hold their breath and then exhale poison at a predetermined distance, yet Atlas did exactly that. As this happened, NASA's key asteroid hunting probe went dark with its crucial data from the closest flyby, mysteriously missing from the public record. Coincidence or cover-up? Tonight, we reveal what the blackout was meant to reveal. Stay with us until the end, because the cover-up ends today. If you're as captivated by these mysteries as I am, hit that like button and subscribe so you don't miss what happens next. As this story continues to develop, leave a comment telling us where you're watching, from what time it is in your corner of the world, and whether you think we're being told the whole truth about these discoveries, or just the version they want us to hear. And if you'd like to help spread the word, share this video on X, Facebook, Reddit, or even your private group chats. You're the force that drives this search for truth. Thank you for standing with us. Part 1. The Poison Switch. Imagine you're an astronomer, your eyes fixed on the vast canvas of the night sky, tracking what seems to be just another cosmic wanderer, a chunk of ice and rock from the depths beyond our solar system. It's routine, almost mundane, until one morning a data spike freezes you in your tracks. The object you've been monitoring, silently gliding through space for years, has suddenly unleashed a molecular torrent of hydrogen cyanide into the void. Not a slow trickle, not a predictable release, but an abrupt, explosive outpouring, as if someone or something flipped a switch. This is no theory. This is hard science. On September 14, 2025, the James Clerk Maxwell Telescope captured an unmistakable signal: hydrogen cyanide emissions from the object known as 3I Atlas, located 2.13 astronomical units from our Sun. The detection was ironclad, with a confidence level exceeding 5 sigma, meaning the odds of this being a false positive are less than 1 in a million. The numbers are staggering: a production rate of 4.0 plus 1.7 x 1025 molecules per second. That's quadrillions upon quadrillions of cyanide molecules streaming off this object every single second. Before you jump to apocalyptic conclusions, let's clarify what hydrogen cyanide is. You might know it as the compound behind the bitter almond scent in certain seeds, or its grim history in chemical warfare, where it suffocates from within by blocking cellular respiration. You breathe, but your cells choke. Yet in the cosmic context, it's not inherently shocking. Comets often harbor hydrogen cyanide locked in their icy cores, released gradually as they warm near the Sun. So finding it isn't the issue. The real question is when and how. Picture the timeline. Throughout August 2025, when 3I Atlas was farther from the Sun, colder, quieter, presumably dormant astronomers trained the James Clerk Maxwell Telescope on it multiple times. They scanned for hydrogen cyanide using the same frequencies, the same methods. The result? Nothing. Not a trace, not a whisper. The spectra were flat, lifeless, silent. Then mid-September rolls in. Atlas edges closer now at 2.1 astronomical units. The telescope takes another look using identical techniques. And suddenly, the hydrogen cyanide signature roars to life, not a slow buildup, not a gentle warming trend, but an instantaneous eruption. Think about that. It's like watching a dormant volcano, cold and still for months, showing no heat, no gas, no tremors. Then one day, without any warning, no magma shifts, no seismic rumbles, it explodes. You'd ask what triggered it. You'd suspect something extraordinary, some hidden mechanism at work. That's where we stand with Atlas. Normal comets follow a predictable script as they approach the sun's solar heat, gradually triggers volatile emissions, first water vapor, then carbon monoxide, then other compounds, each tied to specific sublimation temperatures. Atlas tore up that script. It went from utterly inert to spewing one of chemistry's deadliest compounds all at a distance, where most comets barely stir. Now let's entertain a possibility that sounds wild until you really think about it. What if 3I Atlas isn't just a passive, icy relic drifting aimlessly? What if it's something else, a dormant probe engineered by an unknown intelligence designed to activate at a precise distance from our star? What if that hydrogen cyanide cloud isn't random sublimation, but a deliberate release or even the exhaust of internal systems powering up? I know it sounds like science fiction. Your instinct might be to dismiss it as conspiracy nonsense. But hold on. Over the next hour, I'm going to guide you through a web of events, anomalies, and apparent cover-ups that together weave a narrative far stranger and more unsettling than a simple comet. We'll investigate why NASA's Psyche spacecraft went inexplicably silent during the critical window when it should have captured the clearest images of Atlas. We'll unravel the mystery of Atlas's anti-tail, a bizarre feature pointing toward the sun, defying the basic laws of physics. We'll probe why the European Space Agency is withholding high-resolution spectral data from their Mars orbiters, releasing only low-quality images while claiming they need months to process what should be routine observations. And we'll compare Atlas head-to-head with a typical comet swan to reveal just how anomalous Atlas truly is. By the end, you'll see why a handful of researchers are quietly asking questions that most scientists won't touch in public questions about artificial objects, hidden agendas, and whether humanity is being subtly primed for a truth we're not yet ready to face. But first, we need to dive into the silent week when Atlas unleashed its poison cloud and something peculiar happened with our spacecraft. It's almost as if someone or something doesn't want us looking too closely. And that's where our journey into the unknown begins. Part 2. The Silent Week. NASA's Psyche spacecraft, launched in October 2023, carries a mission that sounds simple enough: journey to the metal-rich asteroid Psyche nestled between Mars and Jupiter, and probe its composition to unlock secrets about planetary cores. Equipped with multispectral imagers, a magnetometer, and a gamma-ray spectrometer, it's essentially a cosmic prospector. But here's where it gets intriguing for our story. While Psyche isn't designed to chase comets or asteroids, its instruments and trajectory make it perfectly capable of observing other objects in the inner solar system during its cruise phase. If something compelling drifts into its field of view, Psyche can capture it in stunning detail. And in early September 2025, something very compelling was about to cross its path. 3I Atlas reached its closest approach to Psyche's position on September 3rd and 4th. The alignment was near perfect. Atlas was bright enough, close enough, and ideally positioned for Psyche's imagers to capture details, surface features, coma structures that ground-based telescopes could only dream of resolving. This was the moment, the window, when we should have gotten our sharpest spacecraft view of Atlas. But instead, we got nothing. Absolute silence. The Psyche mission maintains a public data archive, a treasure trove of processed images regularly updated for researchers, journalists, and space enthusiasts to explore. It tracks the spacecraft's journey from engineering tests to cosmic snapshots. But dig into the archive, scrutinize the timestamps, and you'll uncover something unsettling: a glaring gap. From September 1st to September 7th, 2025, there's not a single image. No observations, no calibration frames, no engineering test shots, nothing. For an entire week, perfectly bracketing Atlas's closest approach, Psyche went dark. Now let's pause for the obvious explanations. Spacecraft aren't always on. They have scheduled downtime for instrument resets, software updates, or telemetry relays when deep space network antennas are busy elsewhere. A glitch might trigger safe mode, shutting down non-essential systems until ground controllers sort it out. Sometimes data processing lags and images don't hit the public archive until weeks later, after calibration and quality checks. These are routine realities of space operations. But here's the problem. NASA hasn't said a word about this gap. No press release about a planned reset. No update mentioning a telemetry hiccup or delayed data. Just silence about the silence. I dug deeper, checked mission status reports, scoured NASA's public communications, reached out through available channels. Nothing. Not a single mention of why Psyche's archive is blank for that critical week. It's as if everyone involved with the mission collectively decided the first week of September didn't need documenting, or that documenting it was too risky for public eyes. Think about what that suggests. If this gap were truly just a coincidence, a routine maintenance window unluckily overlapping with Atlas's closest approach, you'd expect transparency. NASA would say, yes, we were offline. Here's why. We missed Atlas, but here's our next step. Instead, the void screams either gross negligence bordering on incompetence or something far more deliberate, the suppression of data NASA isn't ready to share. Consider the timing. Atlas unleashes its hydrogen cyanide cloud on September 14th, just 10 days after this mysterious blackout. During that silent week, Atlas was close enough for Psyche to capture detailed images. After the blackout, Atlas was farther away, already beginning its chemical transformation. It's almost as if someone ensured no high-resolution images existed from the pivotal moment when Atlas might have been changing, activating, revealing signs of its impending cyanide burst. If Atlas is artificial, if it harbors visible structures, ports, mechanisms, anything betraying a non-natural origin, those features would likely only be detectable up close with spacecraft-grade instruments. Ground-based telescopes, even the most powerful, see Atlas as a blurry dot. Psyche could have changed that game. But during the exact window when it could have, it went silent. Let's entertain a chilling possibility. Imagine Atlas began showing anomalies in late August or early September, panels shifting gas jets firing from precise points rather than uniformly geometric patterns that defy natural fragmentation. Suppose Psyche captured those images and automated systems, or mission scientists flagged them as extraordinary. What happens next? Would NASA rush to share those images with the world? Or would they be whisked away, classified, funneled through security reviews, and shared with defense or intelligence agencies before any public release? I'm not saying this definitely happened. I'm saying the gap in the archive is consistent with it happening. And NASA's utter silence about the gap doesn't exactly scream innocence. This is just the beginning of a pattern we'll see unfold. Data gaps, delayed releases, low-resolution images when high-resolution ones should exist. Spectral analyses that drag on for months when weeks would suffice. It's the blueprint of a soft cover-up, not outright lies, but a calculated control of information, ensuring the public only learns what's deemed safe when it's deemed safe and in the framing authorities choose. Meanwhile, Atlas continues its inward journey, its cyanide cloud growing its true nature obscured. And we're left in the dark, prevented from seeing clearly. But Psyche's blackout is only the first piece of the puzzle. Next, we'll unravel the mystery of Atlas's tail, or rather why it sometimes points in directions that shatter everything we know about comets. The deeper we go, the stranger this gets. Part 3. The Enigma of the Vanishing Tail. Comets at their core are supposed to be straightforward cosmic wanderers, simple yet mesmerizing. Conceptually, they're easy to grasp, even if the physics behind them can spiral into complexity. Picture a comet's nucleus, a gritty snowball of ice rock and cosmic debris. As it ventures closer to the sun, the relentless solar radiation bathes its surface, coaxing ices to sublimate, transforming directly from solid to gas in a silent, ethereal dance. This outgassing lifts fine dust particles from the nucleus, forming a radiant, glowing shroud known as the coma. Then the solar wind, a million-mile-an-hour torrent of charged particles erupting from the sun, sweeps in, shoving the gas and dust away from the nucleus. Sunlight's radiation pressure joins the fray, further sculpting the dust. The result, a majestic tail stretching across the sky, always pointing defiantly away from the sun, no matter the comet's trajectory. This is the ironclad rule of comet physics, a truth humanity has understood since the 17th century. So when a comet's tail dares to point toward the sun, you know you're witnessing something extraordinary, something that defies the very laws of the cosmos. In August 2025, the Hubble Space Telescope turned its gaze toward Comet Atlas, expecting to capture the familiar spectacle of a coma and a tail streaming in predictable elegance. Instead, it revealed something utterly bizarre. Atlas wasn't behaving like a proper comet. It was sporting an anti-tail, a sharp, narrow feature that stretched brazenly toward the sun, defying the solar wind's relentless push. Now, anti-tails aren't entirely unheard of. They can emerge under specific conditions, a cosmic sleight of hand caused by our viewing angle. When we observe a comet from just the right geometric perspective, dust grains lingering in the comet's orbital plane can create an optical illusion, making it appear as though part of the tail is pointing sunward. It's a trick of perspective, a fleeting quirk of geometry. But these anti-tails are typically faint, delicate, and easily explained once the angles are calculated. Atlas's anti-tail, however, was anything but typical. It was bold, persistent, and far too prominent to be dismissed as a mere illusion. The geometry of Earth's position relative to Atlas couldn't fully account for its intensity or endurance. Amateur astronomers, their telescopes trained on Atlas, reported even stranger phenomena. Instead of a smooth, flowing tail, they observed faint, sporadic puffs of gas, erratic jet-like bursts erupting from the nucleus. The coma itself was unpredictable, flaring brightly one moment and dimming to near obscurity the next. Some nights Atlas appeared vibrant with a faint tail trailing behind it, as expected. Other nights, at the same distance from the sun, it looked almost lifeless, a mere speck of light, with a barely discernible coma. This erratic behavior is highly unusual. Once a comet begins actively outgassing, it typically maintains a steady rhythm, its activity tied to the sun's heat. It doesn't flicker on and off like a faulty lantern unless something about its nucleus, its rotation, or its internal structure is profoundly abnormal. Contrast this with Comet Swan, officially designated C2225R2, which graced the skies earlier in 2025. Swan was a celestial masterpiece, a textbook comet that dazzled observers worldwide. Ground-based telescopes captured its massive luminous coma and a sweeping tail that streamed away from the sun in perfect accordance with cosmic law. Amateur astrophotographers shared breathtaking images, revealing intricate shells of gas and dust pulsing outward as Swan's nucleus rotated, exposing fresh ice to the sun's relentless warmth. Swan was everything a comet should be: bright, consistent, predictable, and breathtakingly beautiful. Atlas, by contrast, is a cosmic enigma, dim, erratic, and impossible to pigeonhole. Place images of Swan and Atlas side by side, and you'd struggle to believe they belong to the same class of celestial objects. Swan is the epitome of a comet's grandeur. Atlas. It's as if it's masquerading as a comet, but its performance is just slightly off, like an actor forgetting their lines. So what could explain Atlas's bizarre tail behavior? Let's explore the conventional possibilities first. One potential culprit is fragmentation. If Atlas's nucleus is fracturing chunks of ice breaking away from the main body, could trigger irregular outgassing with different fragments heating at varying rates. Fragmentation events often produce dramatic dust clouds or jets, causing a comet to flare brightly before fading once more. But such events typically leave clear evidence: multiple nuclei expanding debris clouds, or sharp spikes in brightness, followed by a gradual dimming. Atlas, however, shows no obvious signs of splitting apart, no telltale debris scattering across the sky. Another possibility lies in the comet's rotation. If Atlas spins with active vents concentrated on specific regions of its surface, those vents could flare as they rotate into sunlight and dim as they turn away. This could account for the flickering brightness, but it struggles to explain the anti-tail. Rotational jets, like all comet emissions, should still be swept away from the sun by solar wind and radiation pressure. They might create asymmetric or curved tails, perhaps even spiral patterns, but a tail pointing toward the sun. That's a harder puzzle to solve. Could charged dust grains interacting with the sun's magnetic field offer a clue? It's possible. Comets exist in electrically dynamic environments, surrounded by the solar wind, a plasma of ionized particles carrying electric currents. Magnetic fields twist and reconnect in this chaotic realm, and strange phenomena can emerge. If Atlas is producing unusually charged particles, electromagnetic forces might nudge some material in unexpected directions, temporarily overpowering the sun's radiation pressure. This is an exotic explanation, but not impossible. Yet it would require Atlas to be chemically distinct, with dust or gas properties, unlike those of typical comets. This brings us to the heart of the mystery. Why is Atlas so fundamentally different? Here we venture into speculative territory, but speculation rooted in the anomalies we're observing. What if Atlas's tail isn't entirely natural? What if its emissions are directed vents or nozzles releasing gas at specific angles, generating thrust that alters the tail's configuration? Imagine a spacecraft firing its attitude control thrusters. The exhaust doesn't follow the solar wind's dictates. It goes where the thruster points. If Atlas possesses anything resembling propulsion, crude gas jets for orientation or trajectory correction, those emissions could produce the erratic puffs, the intermittent brightening, and the perplexing anti-tail structures that have astronomers baffled. I'm not claiming this is definitively the case, but this hypothesis aligns more closely with the observations than any conventional explanation proposed so far. And here's the unsettling reality: if Atlas is artificial, if it's maneuvering, if it's actively controlling its gas emissions for reasons we can't yet fathom, then we're not dealing with a passive cosmic wanderer. We're confronting something with agency, something that might be responding to its environment, perhaps even activating phenomena like its hydrogen cyanide cloud with deliberate precision. That reframes Atlas, entirely transforming it from a quirky anomaly into a potential threat. To grasp the full implications of this possibility, we must turn our attention to the institutions tasked with studying such phenomena and question why they seem to be withholding answers. The European Space Agency's peculiar handling of Atlas's Mars flyby data raises red flags, hinting at a deeper mystery yet to be unraveled. Part 4. The ESS Lockbox and the Great Data Delay. In the crisp dawn of October 2025, the interstellar comet 32 Atlas executed a daring close flyby of Mars, skimming within a mere 5 million miles of the red planet's rusty surface. This was no ordinary cosmic rendezvous. It was a golden opportunity for scientific discovery. The European Space Agency (ESA), with its arsenal of cutting-edge technology, had two spacecraft poised in Martian orbit: the ExoMars Trace Gas Orbiter and the Mars Express. Both are equipped with sophisticated instruments capable of dissecting atmospheric gases and capturing detailed images of distant objects. As Atlas approached, ESA seized the moment, announcing plans to train their instruments on this interstellar visitor, aiming to capture images and spectra that could unravel the comet's composition and behavior. This was science at its finest, a chance to study an object closer to Mars's orbiters than any Earth-bound telescope could ever hope to achieve, potentially unveiling secrets invisible from our home planet. ESA meticulously positioned their spacecraft, aligned their instruments, and gathered data with the precision of a cosmic symphony. Then the waiting began, a prolonged, tantalizing delay that would come to be known as the ESS lockbox. On October 7, 2025, ESA unveiled their first images of Atlas captured by the Trace Gas Orbiter from a staggering 30 million kilometers away. The images revealed Atlas as a faint pixelated dot against the star-studded expanse, a smudge of light accompanied by a ghostly coma. The scientific community erupted in celebration, hailing the images as a technical triumph. Here was proof that humanity's instruments could peer across the void and glimpse an interstellar traveler from Mars's orbit. It was a testament to international collaboration, a shining example of what space science could achieve. Yet beneath the fanfare, something felt off. The press releases brimmed with enthusiasm, but were curiously light on specifics. The images, while historic, were strikingly low-resolution, fuzzy, almost comically simplistic, like pixelated sprites from a retro video game like Space Invaders. For an agency renowned for delivering breathtaking high-definition portraits of Mars's rugged landscapes, swirling atmospheric phenomena, and intricate moons, these images of Atlas felt oddly rudimentary. Commentators couldn't help but just likening them to crude, cartoonish blobs against a stark black backdrop. Where was the clarity? Where was the detail? More puzzling still was ESA's handling of the spectroscopic data, the crown jewel of this observational campaign. Spectroscopy, the art of analyzing light to reveal an object's chemical fingerprint, promised to decode Atlas's essence, the gases it was emitting, the molecules it harbored, the isotopic ratios that could hint at its origins. This was the data that could tell us whether Atlas was a typical interstellar comet or something far stranger. Yet ESA announced that this treasure trove of information would remain under lock and key for months pending exhaustive analysis. Months for spectroscopy, a process that at its core is relatively straightforward. Point a spectrometer, collect photons, analyze wavelengths, and identify the telltale signatures of molecules. This isn't frontier science requiring years of theoretical modeling. It's routine observational astronomy. Even with meticulous calibration, weeks should suffice. So why the protracted delay? Let's probe deeper. We already know Atlas is spewing hydrogen cyanide at an astonishing rate, a toxic hallmark that sets it apart. But what else lurks in its chemical makeup? Are there exotic molecules that defy the profiles of natural comets? Do its isotopic ratios suggest materials forged in alien conditions, far removed from our solar system, or the expected chemistry of interstellar space? Could there be traces of artificial compounds, molecules that nature doesn't craft? These are the questions spectroscopy could answer, and they're precisely the questions ESA seems reluctant to address swiftly. By withholding the data, ESA maintains a tight grip on the narrative. When the results finally emerge, they'll likely be meticulously vetted, carefully contextualized, and presented in language that tempers excitement and prioritizes scientific caution. This isn't definitive proof of a cover-up, but every aspect of ESA's approach aligns with institutional gatekeeping. Contrast this with their handling of past discoveries. When Mars Express detected methane plumes in the Martian atmosphere, data was released within weeks, igniting a spirited debate about biological versus geological origins. When the Trace Gas Orbiter mapped water vapor in Mars's skies, results were shared promptly. Those findings were thrilling but safe. They didn't upend our understanding of the cosmos. Atlas, however, is different. An active interstellar object venting toxic gases near Earth's orbit is unprecedented. If its composition hints at artificial origins, if its chemistry defies natural processes, the implications are nothing short of earth-shattering. This brings us to the question of coordination. ESA doesn't operate in a vacuum. They share data with NASA, other space agencies, and even defense and intelligence communities. If Atlas's observations revealed something truly anomalous, say evidence of artificial construction, that information wouldn't remain confined to ESA's Science Directorate. It would be escalated, classified, and deliberated at levels far removed from public-facing researchers. Scientists might be instructed to slow their analysis, to triple-check every finding, to ensure no premature conclusions slip out, not out of malice or conspiracy, but because institutions instinctively gravitate toward caution when faced with data that could spark panic or geopolitical upheaval. Make no mistake, confirmation of Atlas's artificial nature would be a seismic event. It would unleash a torrent of questions. Who built it? Why is it here? What is its purpose? Does it pose a threat? Are there more like it? These are questions no government, military, or international body is fully prepared to answer. So ESA plays the long game. They release innocuous images that reveal nothing controversial, promise that detailed analysis is forthcoming, and urge patience. Science takes time, they say. Meanwhile, Atlas hurtles closer to the sun, closer to Earth, and those with access to the best data remain silent about what they truly see. Yet we're not entirely blind. We can piece together clues by comparing Atlas to other celestial objects. We can leverage the observations we do have to build a compelling case. One of the most striking pieces of evidence emerges from a simple question. If Atlas were just a comet, how would its behavior stack up against a typical comet observed during the same period? The answer is devastatingly revealing. But before we dive into that comparison, we must confront an even more chilling possibility. What if Atlas's hydrogen cyanide cloud isn't merely an emission? What if it's a weapon? Part 5. The weaponized cyanide hypothesis. Picture this, a sinister cloud of poison drifting through the vastness of space, a toxic specter conjured from the depths of a cosmic nightmare. It sounds like the fevered plot of a low-budget sci-fi flick. Think evil aliens blanketing Earth with deadly gas from their orbiting fortress. But before you dismiss this as pure fantasy, let's dive into the chilling reality of the physics at play. The science behind this scenario is far from absurd, and it demands our attention. The mysterious object known as Atlas is churning out hydrogen cyanide at a staggering rate of approximately 4 × 1010 molecules per second. That number is so colossal, it's almost impossible to grasp. So let's paint a vivid picture. If you were to capture Atlas's output for just 1 hour, you'd have enough hydrogen cyanide gas to fill several Olympic-sized swimming pools. Let that sink in. Now imagine this deadly production continuing unabated for days, weeks, or even months. The resulting cloud of poison would balloon into something truly monstrous, a gaseous leviathan lurking in the void. But space is no small stage. It's an incomprehensibly vast arena where gases expand with reckless abandon in the vacuum. As this cyanide cloud spreads, its concentration plummets, dramatically governed by the merciless inverse square law. Double the distance from the source, and the concentration dwindles to a mere quarter. Triple the distance, and it's reduced to a ninth. By the time any trace of Atlas's toxic cloud could reach Earth, it would be so thinly dispersed that detecting it would be a challenge, let alone suffering its lethal effects. The cloud, once a terrifying behemoth, would dissolve into a harmless whisper across the cosmic expanse. Earth's atmosphere, a steadfast guardian, further diminishes the threat. Even if a dense plume of hydrogen cyanide somehow made its way to our planet, it would face a fiery demise in the upper atmosphere. There, it would break apart into innocuous atoms, never reaching the surface in concentrations potent enough to cause harm. For Atlas's cyanide to pose a real danger, it would require an almost apocalyptic alignment of circumstances, a targeted, sustained release of poison directly into Earth's orbital path, coupled with extraordinarily unlucky atmospheric dynamics. Naturally, this scenario is beyond improbable. It's practically impossible. But here's where the story takes a darker, more speculative turn. What if this isn't a natural phenomenon at all? What if Atlas is no mere celestial wanderer, but an engineered construct designed with malevolent intent? Could it possess the capability to manipulate its trajectory and emissions, orchestrating a deliberate strike to deliver a concentrated cloud of poison to a precise target, Earth? This idea, while teetering on the edge of science fiction, isn't entirely beyond the realm of possibility. Imagine Atlas equipped with a sophisticated propulsion system, subtle and cunning, perhaps harnessing its own outgassing as a form of reaction mass. Such a system could allow it to make minute trajectory adjustments invisible to our telescopes, which expect cometary orbits to obey the predictable tug of gravity. These covert maneuvers could position Atlas at its perihelion, its closest approach to the Sun, directly in Earth's orbital path. Then, at the precise moment of opportunity, Atlas could unleash a concentrated burst of hydrogen cyanide, not scattered aimlessly in all directions, but funneled through a directed nozzle or vent, aimed with lethal precision at Earth's predicted position. This chilling hypothesis forces us to confront a question as tantalizing as it is terrifying. Could Atlas be more than a cosmic curiosity? Could it be a weapon lying in wait, ready to strike? The answers lie in the shadows of speculation, but the science keeps us tethered to a haunting possibility we cannot entirely dismiss. The cloud unfurls, a sinister veil stretching across the cosmos, its path meticulously calculated to collide with Earth's orbit at the exact moment our planet sweeps through that perilous region. This is no mere celestial drift. It's a fusion of cold, precise orbital mechanics and the chilling specter of chemical warfare. Could such a scenario be possible? In principle, absolutely. But its feasibility hinges on the enigmatic capabilities of Atlas, a celestial enigma, whose true nature remains shrouded in mystery. Let's unravel the engineering marvels required to orchestrate such a cosmic ambush. First, propulsion. To nudge its trajectory even by a fraction, Atlas would need a mechanism to alter its velocity with surgical precision. Gas jets could be the answer, expelling volatile material asymmetrically to generate thrust, much like the small thrusters spacecraft use for attitude control. If Atlas harbors internal reservoirs and controllable vents, it could deftly adjust its course, steering toward a fateful rendezvous with Earth. This isn't science fiction. It's a proven technique in space exploration, repurposed for a far darker intent. Second, targeting. To execute this interstellar gambit, Atlas would need to know Earth's position, predict its future location, and compute intercept trajectories with pinpoint accuracy. This demands sophisticated sensors, advanced computational systems, and precise ephemerides tools, well within the grasp of any spacefaring civilization. The mathematics of orbital dynamics are unforgiving, but they are solvable, and Atlas, if engineered, would wield this knowledge like a master strategist, plotting a cosmic checkmate. Third, timing. The release of hydrogen cyanide would need to be orchestrated with exquisite precision, timed to the moment when Atlas's position ensures the expanding toxic cloud intersects Earth's orbit at the perfect instant. This is no random outburst. It's a calculated maneuver grounded in the same orbital mechanics that guide spacecraft and predict planetary alignments. The problem is complex but eminently solvable. A puzzle any advanced technology could crack with ease. Now brace yourself for a chilling possibility. The sudden eruption of hydrogen cyanide at 2.1 astronomical units might not be a random anomaly. It could be a deliberate test, a systems check to verify that ancient mechanisms still hum with life, that chemical pathways remain viable, that storage containers have endured the eons of interstellar travel without leaking or degrading. Imagine a probe dormant for centuries, powering up to confirm its deadly payload is ready. It releases a cloud, monitors its expansion, and observes whether Earth's ground-based telescopes notice and how humanity reacts. This could be a prelude, a dress rehearsal for a far deadlier act, closer to perihelion, where Atlas refines its targeting, gathers data, and awaits the optimal moment to unleash its full potential. This is how you'd engineer a reconnaissance and delivery system, an interstellar weapon built with redundancy verification stages and fail-safes to ensure its mission succeeds. The September emission might be precisely that, a pre-deployment test, a signal that Atlas is awake and operational. If true, the implications are bone-chilling. We're not facing a passive, inert object that might accidentally endanger us. This is an active threat, a machine capable of responding to its environment, following a programmed sequence, pursuing objectives we can only guess at, with growing dread. Consider the muffler analogy. If Atlas houses a massive internal engine, powering propulsion communication or other systems, that engine would produce exhaust. Hydrogen cyanide could be the chemical signature of this alien technology, a byproduct revealing the inner workings of a machine that's just roared to life. Just as a car's exhaust betrays its combustion, Atlas's emissions might expose its activation. The sudden appearance of this chemical cloud, precisely as observed, aligns more convincingly with this hypothesis than with the chaotic unpredictability of natural comet behavior. Let's map out the worst-case scenario. Atlas entered our solar system as a sleeper probe, silent and dormant, conserving energy and blending seamlessly with the countless inert rocks drifting through the void. To all appearances, it was just another interstellar wanderer. But as it neared the sun, internal systems sprang to life, triggered by pre-programmed thresholds, solar radiation levels, distance, or trajectory alignment. At approximately 2.1 astronomical units, activation protocols kicked in. Systems powered up, chemical reservoirs unsealed, and hydrogen cyanide vented both as a test and as a byproduct of engine ignition. Ground-based observers peering through telescopes detected the anomaly, a sudden emission defying the norms of cometary behavior. Mainstream science, tethered to familiar paradigms, chalked it up to natural processes. But Atlas, undeterred, pressed inward, refining its trajectory as it approached perihelion at roughly 1.36 astronomical units. There, solar heating would intensify, and natural cometary activity would peak, providing the perfect camouflage for further emissions. If Earth's orbit aligns with this toxic cloud at the wrong moment, a concentrated wave of hydrogen cyanide could envelop our planet, a threat we never anticipated, because we dismissed Atlas as just a comet. Let's be clear, this scenario rests on bold assumptions. It assumes Atlas is artificial, endowed with capabilities we haven't directly observed, driven by intentions we can only infer. Every attempt to shoehorn Atlas into the mold of a typical comet leaves nagging anomalies unresolved: the abrupt onset of emissions, the peculiar anti-tail, the mysterious spacecraft blackouts, the perplexing data delays. At some point, The pile of unexplained oddities forces us to entertain hypotheses we'd rather ignore. The weaponized cyanide scenario, as unsettling as it is, fits the data with disturbing precision. But there's a broader, more ominous context to consider: a tangled web of conspiracy theories and hidden agendas, hinting that Atlas might be a piece of a far stranger puzzle. To grasp the full scope of this mystery, we must delve into the shadowy realm of Project Bluebeam, where the lines between science speculation and cosmic intrigue blur into something far more unsettling. On Part 6, the Bluebeam Trigger Protocol Unveiled. There exists a conspiracy theory so audacious, so vividly cinematic, that it captivates even the most resolute skeptics, drawing them into its intricate web of intrigue, even if they remain unconvinced of its truth. This is Project Bluebeam, a purported clandestine scheme orchestrated by shadowy global elites, wielding cutting-edge technology to stage a jaw-dropping, world-altering spectacle of fabricated alien invasion. This elaborate ruse, according to its proponents, would harness advanced holographic displays, satellite-based projection systems, and sophisticated electromagnetic manipulation to conjure a terrifyingly realistic extraterrestrial threat in the skies above. The ultimate goal of this cosmic deception: to plunge the global population into a state of primal fear, compelling humanity to relinquish national sovereignty and embrace a unified authoritarian world government in exchange for promised protection against the manufactured alien menace. It's the quintessential false flag operation, a celestial sleight of hand designed to exploit humanity's deepest existential anxieties for the sake of consolidating political power on an unprecedented scale. While most researchers dismiss Project Bluebeam as a fevered blend of unfounded paranoia and science fiction, fantasy melding genuine concerns about government propaganda with far-fetched otherworldly tropes, the theory commands a fervent following within the conspiracy community. For these believers, Bluebeam is not mere speculation, but a chillingly plausible playbook complete with a meticulously outlined detection protocol to identify its activation. This protocol serves as a guide for spotting the subtle orchestrated shifts that signal the plan is in motion. Here's how the protocol unfolds. For decades, mainstream science and media have systematically debunked UFO sightings, ridiculed eyewitness accounts, and maintained an unwavering stance that extraterrestrial visitation is not just improbable, but virtually impossible. This entrenched skepticism has been the bedrock of public discourse on the subject. However, the Bluebeam Protocol warns that a sudden dramatic reversal of this narrative is the critical telltale sign. If prominent skeptics, scientists, journalists, or government officials begin to validate the existence of an alien presence, if governments openly admit to tracking unidentified aerial phenomena, or if the media pivots from mockery to earnest reporting, these are not mere coincidences. They are deliberate signals that the Bluebeam machinery is being activated, the stage is being meticulously set, and the public is being psychologically primed for the grand deception. The holographic projectors believers claim are warming up for their starring role. When the fabricated invasion finally unfolds, the theory posits that the world will accept it without question, precisely because trusted authorities, scientists, governments, and media outlets have already laid the groundwork by affirming the reality of extraterrestrial life. This is predictive programming at its most insidious, a carefully choreographed campaign to shape public perception, followed by the execution of the ultimate cosmic charade. Once you're aware of this telltale flip in the narrative, it becomes impossible to ignore the signs when they appear. And appear they have. In recent years, the cultural and institutional landscape has undergone a seismic shift that aligns eerily with the Bluebeam Protocol. The U.S. government has declassified a trove of UFO videos, thrusting once classified footage into the public domain. Pentagon officials have testified before Congress about encounters with unidentified aerial phenomena, lending official weight to discussions once relegated to the fringes. Media outlets, which for decades scoffed at UFO enthusiasts, now publish measured, serious analyses of military encounters with unexplained craft. Even NASA, the pinnacle of scientific authority, has launched dedicated research programs to investigate UAPs. The narrative surrounding extraterrestrial life has pivoted sharply from a topic dismissed as conspiracy fodder to one treated with gravitas and urgency. For staunch believers in Project Bluebeam, these developments are not mere coincidences or signs of evolving scientific curiosity. They are unmistakable evidence that the trigger has been pulled. The grand illusion they warn is already in motion, and the world is being groomed for a spectacle that will reshape humanity's future forever. And now, quite conveniently, an interstellar object makes its appearance, acting bizarrely, releasing toxic gases and resisting any simple explanation. Could Atlas be the test balloon? The opening act, the warm-up event designed to prepare the public for what comes next. Let's examine this hypothesis carefully. Suppose the blue beam is real, or at least imagine that powerful interests aim to manipulate public perception concerning extraterrestrial threats. Atlas fits that purpose perfectly. It's real, visible to both amateur astronomers and professional observatories alike. Faking it would be nearly impossible, as countless independent observers are tracking its every move. But the narrative surrounding it can be controlled. Data can be selectively released, certain anomalies highlighted while others are quietly minimized, and public concern can be gradually intensified step by step. You begin with, "It's just a comet." Then comes, "It's emitting strange gases." Next, "Its behavior defies our models." After that, we're observing structures that don't seem natural. Each revelation heightens anxiety, priming the audience for what follows. Eventually, when the time comes for the grand reveal, whether it's a staged holographic invasion or a genuine first contact, the public is already halfway prepared to believe it. They've been conditioned to anticipate something extraordinary. The technology needed for Bluebeam remains speculative, yet not entirely beyond reach. Satellite-based laser projection could generate vast atmospheric displays visible across immense regions, especially under the cover of night. Combine that with drones projecting synchronized images, and you could simulate entire fleets of spacecraft. Introduce electromagnetic frequency manipulation, targeting the human brain's sensitivity to specific wavelengths, and you might trigger mass hallucinations or auditory phenomena. Add tight media control, ensuring every outlet echoes the sanctioned narrative, and you've crafted the blueprint for a manufactured reality. Whether such technology exists at the scale Bluebeam demands is debatable, but components of it undeniably do. The real question is whether anyone possesses both the will and the means to deploy it. And this is where Atlas fits in with unsettling precision. If you intended to stage an invasion, beginning with a small distant object, would be entirely logical, contained, controllable, and easy to frame. It doesn't trigger mass panic right away, it lets authorities regulate the tempo. They can observe how the public responds to early anomaly reports, measure which narratives gain momentum online, and refine their strategy through real-time feedback. Atlas becomes a living experiment, a psychological operation disguised as an exercise in astronomical observation. And because it's real, because telescopes truly detect it, skeptics can't simply dismiss it as fabrication. They're compelled to confront the data, to rationalize the anomalies, to wrestle with possibilities they'd prefer to reject. Meanwhile, the public observes, absorbs, and gradually transitions from disbelief to uneasy acceptance of the notion that something out there isn't quite what we thought. Critics of Bluebeam highlight its inherent logical flaws. Orchestrating a global deception of such magnitude would demand unparalleled coordination among governments, space agencies, militaries, and media networks, spanning dozens of nations with conflicting agendas. Leaks would be unavoidable. Whistleblowers would inevitably surface. The entire operation would likely crumble beneath its own complexity, and those are entirely valid objections. Yet consider an alternative. What if Bluebeam isn't a grand coordinated conspiracy, but an emergent strategy instead? What if numerous actors, each advancing their own agendas, independently converge on the same tactic, wielding the alien threat narrative to secure funding, maintain control, or divert attention from deeper crises? You don't need a hidden cabal when structural incentives naturally steer everyone toward the same course of action. And in that scenario, Atlas doesn't have to belong to some grand design. It merely needs to be useful, a convenient crisis that multiple interests can exploit at once. I can't say whether Project Bluebeam is real nor whether Atlas is entwined with it, but I do know the pattern is there. I can see the narrative evolving, shifting right before our eyes. And I know that when patterns begin to surface, when the improbable starts to feel inevitable, it's worth asking who stands to gain. Yet let's pull back from the conspiracy lens for a moment and look at a different pattern. One quietly noted by astronomers for years. One implying that Atlas may not be an exception at all. One that leads to a single unsettling question. What if the stars themselves aren't what they seem? Part 7. The Pattern of Vanishing Stars. Beatrice Villa-Hoyle may not be a name familiar to most yet. Her research stands among the most unsettling developments in modern astronomy. Her work doesn't focus on what appears in the night sky, but on what quietly disappears from it. Working with historical photographic plates, the fragile glass negatives captured by telescopes across the 20th century and preserved in observatory archives worldwide, Vero began meticulously cross-referencing these antique sky surveys with modern digital observations. Her objective was simple, almost deceptively so: to find celestial objects that once appeared in those vintage images, but have since vanished from the heavens. She named her project VASCO, Vanishing and Appearing Sources, during a century of observations. What she uncovered should have shaken the scientific world. By comparing data from the U.S. Naval Observatory's archives, she identified roughly 100 sources that appeared as stars or star-like points of light in the 1950s, yet had no trace in modern sky surveys. They had quite literally disappeared. But before we jump to extraterrestrial conclusions, let's pause and consider the more conventional explanations. Photographic plates are notoriously temperamental. Emulsions deteriorate over time. Cosmic rays can leave deceptive pinpricks of light. Developer chemicals sometimes create lingering artifacts. Dust motes on the glass can masquerade as stars, while atmospheric distortions during exposure may conjure ghost images that never truly existed. All of these are valid concerns, and Varel's team tackled them methodically, eliminating each potential source of error one by one. They meticulously filtered out obvious artifacts, cross-checked multiple plates from different observatories, and concentrated on cases where the vanished object appeared consistently across several exposures. The result? A subset of disappearances that defied easy explanation by instrumental flaws or chemical errors. These objects were undeniably real in the 1950s and are genuinely absent today. So what happened to these vanished stars? Mainstream astronomy proposes several natural explanations. A failed supernova, for instance, might cause a star to briefly brighten to detectable levels before collapsing into obscurity. Lens flares from nearby bright stars could produce phantom points of light. Extreme stellar variability might make a star visible during one observation and vanish entirely during the next. Photometric calibration errors could misclassify the brightness of distant background galaxies, making them appear star-like, when in fact they're too faint for modern surveys to detect at those magnitudes. Such explanations account for many, perhaps most of the vanishing star candidates. Yet Villa-Hull insists that a small but stubborn residual remains cases where none of the conventional explanations align satisfactorily. And that's where things take an intriguing turn. Suppose, for the sake of argument, that some of these vanished objects were never stars at all. Suppose they were artificial light sources, beacons, or probes stationed within our solar system, or in nearby interstellar space, active during the mid-20th century. For purposes we can't yet comprehend, before powering down, departing, or deliberately concealing themselves. How could we tell them apart from real stars? Photographic plates offer limited resolution and sensitivity. A point source is just a point source. If a probe aimed to disguise itself as a star sustaining a steady luminosity and remaining motionless relative to the background over human timescales, it could effortlessly deceive observers for decades. Then, when its mission ended, or its power source finally ran dry, it simply shut down. The star vanished, and we were left bewildered, crafting astrophysical explanations for something that was never astrophysical at all. And this is where the connection to Atlas becomes deeply unsettling. If Atlas is artificial, if it's a probe from a non-human intelligence, then it's probably neither the first nor the only one. Civilizations capable of interstellar travel wouldn't dispatch just a single scout, they'd deploy fleets, networks, and redundant systems. Some probes might be passive observers stationed in stable orbits to watch and record. Others could be active explorers approaching stars, sampling atmospheres, and investigating planets. Over centuries or millennia, their operational status would fluctuate. Some would fail, others would complete their missions and then power down. Some would relocate. For us, detecting them would hinge on luck and persistence. We might catch a fleeting glimpse, catalog it as a comet or asteroid, then lose it as it maneuvers or powers down. Or we might observe it as a faint, star-like point, never realizing its artificial nature until it disappears without a trace. The implications are staggering. If even a fraction of Villarroel's vanishing stars are indeed artificial, then our solar system and the nearby reaches of interstellar space are far more inhabited than we've ever imagined. We are not solitary wanderers in a cosmic void. We are residents in a neighborhood, perhaps even a crowded one. And we've remained oblivious simply because our observational tools can't easily tell the difference between natural and artificial point sources. Atlas might belong to that concealed population, one probe among many set apart, only because it activated at a time when our detection technology had finally become sensitive enough to register its peculiarities. And if that's true, then Atlas's sudden release of hydrogen cyanide might not signal an impending attack on Earth at all. It could be a transmission, a communication burst directed toward other probes, part of a coordination protocol we've stumbled upon by accident. Think about the weight of that possibility. We may be eavesdropping on a conversation we can't comprehend, exchanged between participants we cannot see in a language we have yet to decipher. Atlas emits hydrogen cyanide, and we've labeled it a toxic plume, a poison cloud. But what if it's something entirely different? What if those emissions are a message encoded in molecular patterns meant to be read by sensors on other probes scattered throughout the system? What if the anti-tail, the erratic jets, the precise timing of each burst together form a structured data packet, a transmission declaring arrival confirmed? Systems operational, proceeding to next waypoint. We wouldn't recognize it as communication because we're tuned to expect radio waves or laser pulses, not chemical plumes. But an advanced civilization might communicate through means far beyond our conventional expectations, using chemistry, biology, or physics we've only begun to grasp. They could encode data in forms and forces we overlook, embedding information within the very fabric of natural phenomena we take for granted. The vanishing stars, the sudden emergence of Atlas, the inexplicable behaviors, all of it hints at a concealed layer of reality functioning just beyond the edge of our perception. And if we're only beginning to detect it now, it's likely because our instruments have only recently grown sensitive enough to perceive the faint traces of what's always been there. But alongside this awakening lies another force, a control mechanism shaping not just what we see, but how we interpret it. One that discourages us from looking too closely, one that limits who is permitted to reach into that darkness. It isn't hidden in shadows or myths. It's written into law, enforced by governments and accepted by the public without hesitation. So let's talk about that gatekeeper. Let's talk about who's actually allowed to speak to the stars. Part 8. Radio Silence Regulation. You can listen to space all you want. Build a radio telescope in your backyard, aim it skyward, sweep across the frequencies, and record whatever signals you find. That's perfectly legal. Governments even encourage amateur radio astronomy. Universities share open data from professional observatories. The universe itself is endlessly talkative pulsars ticking like cosmic metronomes. Quasars blazing across light years, the cosmic microwave background humming softly at 3 Kelvin. You can listen to all of it, but the moment you try to speak back, everything changes. Transmitting outward, sending a message into the void, means stepping into a labyrinth of regulations, licensing requirements, and unwritten prohibitions that in practice reserve deep space communication for government-authorized entities. Why? If space is supposedly empty if no one's out there listening, why should it matter who transmits? The International Telecommunication Union (ITU) controls the allocation of the global radio spectrum. It designates frequency bands for terrestrial communications, satellites, navigation systems, and radio astronomy. Some of those bands are quiet zones protected for passive listening, so that natural cosmic signals aren't drowned out by human noise. Transmitting in those frequencies is strictly forbidden, fair enough, since interference could ruin sensitive scientific observations. But the restrictions go far beyond that. High-power transmissions, especially those directed beyond Earth, often require special authorization. The exact rules vary from country to country, but in many jurisdictions, broadcasting toward space falls under both telecommunications and military communications law. In other words, you can listen to the cosmos freely, but speaking to it is another matter entirely. The explicit justification is simple spectrum management and interference prevention. The implicit justification is control. Consider the logic. If authorities truly believed that extraterrestrial intelligence doesn't exist, or that no one out there is listening, there would be no harm in letting anyone transmit. You could shout into the void without consequence. But if there's even a chance that something is listening, then unregulated transmission becomes a potential risk. What if an amateur astronomer tinkering with a homemade transmitter sends out a message that draws attention, a message that's misinterpreted, or worse, provokes a response? What if that response is hostile or merely perceived as such, sparking an interstellar misunderstanding that governments are utterly unprepared to manage? From that perspective, keeping transmission rights centralized makes sense. Official channels, military oversight, diplomatic containment. That's the pragmatic explanation. The paranoid explanation cuts deeper. It suggests that governments restrict outbound communication because they've already made contact, or they expect to and they want to control that dialogue entirely. They don't want civilians complicating negotiations or exposing what's been concealed. There's precedent for this kind of silence. During World War II, ships observed radio silence in hostile waters to avoid detection by enemy submarines. The same logic could extend into the cosmos. If hostile probes are listening, analyzing, and triangulating our signals, then every broadcast we send becomes a beacon, a locator tag declaring, "We're here." Silence in that framework is survival. But here's the irony: we haven't truly been silent at all. For more than a century, humanity has been broadcasting unintentionally, our television radar and communication signals radiating outward, like a faint electromagnetic halo announcing our presence to anyone or anything that knows how to listen. Radio, television, radar, all of it leaking into space for decades, an unintentional broadcast announcing our presence to anyone nearby with the sensitivity to detect it. Any sufficiently advanced intelligence within a few dozen light years already knows we're here. So the rationale for enforced silence collapses, unless the goal isn't to hide our existence, but to control the content of any deliberate message we might send. Let's speculate. Suppose governments detected anomalous signals decades ago, subtle fluctuations in background noise that hinted at artificial origin. Suppose they replied quietly, tentatively, through classified channels, establishing a fragile dialogue with whatever was out there. And suppose that dialogue never stopped continuing under layers of secrecy mediated by agencies operating on frequencies the public can't monitor. In that scenario, civilian deep space transmission isn't just a regulatory nuisance. It's a threat, an unpredictable variable that could interfere with an ongoing exchange, reveal state secrets, or expose the very existence of that contact. The regulations then aren't truly about spectrum management or preventing interference. They're about containment of information, of narrative, of truth. And if Atlas belongs to that hidden ecosystem, a probe dispatched by whoever's on the other end, its sudden activation might not be random at all. It could correlate with a signal we sent or one we received, a diplomatic moment that quietly escalated from communication to action. An amateur radio operator once described his own frustration with this system. He'd built an impressive antenna array capable of detecting faint deep space signals. He wanted to conduct independent SETI experiments, listening for structured patterns, and if he found something, sending a reply. But when he looked into the legal requirements for transmitting beyond Earth, he hit a wall. Agencies demanded exhaustive technical details, insisted on government oversight, and ultimately discouraged him from ever transmitting. The message couldn't have been clearer. Listening is permitted, speaking is not. He took that as confirmation that authorities don't want the public engaging independently with any potential extraterrestrial intelligence. And perhaps he's right. Perhaps the silence protocols were never meant to protect us from aliens, but to protect the secret from us. Now connect that to Atlas. If civilian transmission is restricted, if only authorized entities can legally broadcast into space, then any signals Atlas might be receiving, any communication patterns it's responding to, must originate from those same official government-sanctioned sources. That means we're not merely watching Atlas. We may be participants in an interaction choreographed by agencies beyond public accountability. And if something in that exchange goes wrong, if Atlas misinterprets a signal as a threat or acts on instructions we can't decipher, we'll live through the consequences without ever knowing what triggered them. The radio silence regulation ensures precisely that a public kept blind, uninformed, and effectively powerless. And ignorance when facing potential existential contact is the most dangerous stance imaginable. But ignorance may not last much longer. Atlas is drawing closer to perihelion, its nearest pass to the sun. That's when energy spike systems awaken and events accelerate. Whatever Atlas truly is, whatever conversation it's part of that moment, could mark the point where control slips away from governments, from institutions, from all of us. Part 9. Solar sabotage at perihelion. Perihelion marks the moment of maximum solar influence for Atlas. According to current orbital models, its closest approach, about 1.36 astronomical units from the Sun, is projected for late November 2025. That's roughly 127 million miles, comfortably beyond Earth's orbit, yet deep enough into the solar furnace for sunlight and radiation to surge in intensity. For an ordinary comet, perihelion is its moment of brilliance. Surface ices vaporize in a frenzy. Dust jets erupt and spread, swelling the coma to peak luminosity. The tails bloom long, ghostly ribbons, stretching millions of miles into space. Then, as it arcs away from the Sun, the display fades, leaving behind a fading trail of debris. But if Atlas isn't a comet, if it's an engineered construct disguised as one, then perihelion could mean something entirely different. It could be an activation window, the point when dormant systems awaken as solar energy floods onboard circuits, charging capacitors, igniting dormant subsystems. Because the Sun isn't just a lamp, it's a reactor. A constant nuclear storm broadcasting power across the electromagnetic spectrum, from gentle radio waves to blistering gamma rays. Its solar wind, a 1,000,000-mile-per-hour torrent of charged particles, can batter magnetic fields and energize any system designed to harvest that kinetic chaos. Its magnetic fields twist, snap, and release coronal mass ejections, colossal bursts of plasma that can overload satellites, fry electronics, and ripple through planetary magnetospheres. To a passive rock, these are hazards. But to an active machine, their potential energy sources, raw solar currents, to be harnessed, stored, and used. And that's the critical point: the Sun provides power. For any device built to feed on light, heat, and plasma, perihelion isn't danger, it's opportunity. Any spacecraft operating within the inner solar system relies on solar power. It's plentiful, predictable, and requires no expendable fuel. If Atlas possesses solar panels or some analogous energy harvesting system, its power output would scale with its proximity to the Sun, increasing roughly quadratically as distance decreases. At 136 AU, solar irradiance is about half the strength experienced at Earth's orbit, still ample to recharge batteries, awaken dormant subsystems, and trigger pre-programmed routines. Imagine Atlas designed for deep space endurance, a probe set to hibernate during its long interstellar drift, conserving every watt, minimizing emissions, and appearing inert for centuries. As it entered our solar system, its passive sensors would register the gradual rise in solar radiation. At a defined threshold, say 2.1 AU, the first systems would stir. Preliminary circuits power up, venting hydrogen cyanide, either as a diagnostic test, a byproduct of activation, or even a signaling event. Now, as Atlas nears perihelion, the primary systems prepare to engage. Whatever Atlas was built to accomplish it would execute that mission precisely when its energy intake peaks. That could mean launching subsidiary probes, transmitting data back to its origin, adjusting trajectory for a close planetary pass, or deploying something entirely unexpected. And the beauty, if that's the word, is in the camouflage. A natural comet becomes spectacularly volatile near perihelion. Observers anticipate outgassing, unpredictable jets, brightness, surges, fragmentation, chaotic behavior that's entirely explainable by cometary physics. Any artificial anomalies would blend seamlessly into the noise of natural expectation. But there's another layer of complexity: the Sun itself is not constant. It breathes in cycles roughly every 11 years, oscillating between solar minimum when its surface quiets and solar maximum when sunspots flares and coronal mass ejections erupt with violent frequency. Atlas's approach in late 2025 coincides uncomfortably with the rising phase of solar cycle 25, edging toward a peak in solar activity. For a natural comet, that means turbulence. For an artificial one, it could mean opportunity or intention. We are indeed approaching the next solar maximum forecast for 2025-2026. That means Atlas's perihelion aligns almost perfectly with a period of heightened solar turbulence, an era of intensified flares, coronal mass ejections, and electromagnetic chaos. If Atlas is an engineered construct designed to utilize or react to solar activity, the timing couldn't be more precise. A CME rich in charged particles and magnetic energy could serve as both a power surge and a smokescreen, recharging systems, initiating protocols, or concealing outbound transmissions within the natural roar of solar noise. From Earth, such an event would appear indistinguishable from routine cosmic weather. Ground-based sensors would drown in the sun's static. Artificial signals would vanish beneath the flare's fury. It would be in every sense perfect cover. Now consider a worst-case scenario. Late November 2025, Atlas reaches perihelion. A mid-scale CME erupts from the solar surface, expanding outward in a vast ionized wave. Atlas's trajectory places it squarely in its path. The plasma cloud engulfs the object, flooding it with electromagnetic energy and high-velocity particles. Inside that storm, Atlas responds exactly as designed. Vents open. Stored volatiles ignite, releasing controlled jets of gas to produce thrust. The probe shifts course, subtly altering its trajectory toward a calculated intercept with Earth's orbital plane. Simultaneously, additional emissions, perhaps including concentrated hydrogen cyanide or other volatile compounds, are expelled along predetermined vectors that will intersect Earth's position weeks or months later. To telescopes and observatories, the scene looks unremarkable. A comet flaring brightly at perihelion, shedding gas, maybe fragmenting a little, displaying textbook cometary behavior. The illusion holds until it doesn't. By the time we realize Atlas isn't following the natural arc of a comet, but executing a controlled maneuver, it could already be too late to intervene. Is this physically plausible? Yes, disturbingly so. The mechanics of propulsion via directed gas release the timing with solar activity. The masking effect of CMEs all align with established principles of celestial dynamics and energy physics. Whether Atlas is truly capable of such intent remains unproven, but if it were, perihelion wouldn't be a passive event. It would be the ignition point. Orbital mechanics makes trajectory adjustment entirely feasible. Directed thrust changes velocity. Chemistry supplies the propellant. Solar power delivers the energy. The only missing piece is engineering, and that conveniently is what we can't verify. The data that could answer that question is fragmented, delayed, or quietly withheld. NASA's Psyche mission went silent during the optimal window for cross-observation. ESA is sitting on unreleased spectroscopic analyses. Hubble captured frames showing structural irregularities, promptly dismissed as projection artifacts. The pattern is familiar, every anomaly smoothed, every inconsistency explained away. The architecture of a potential catastrophe is already assembled. The only remaining uncertainty is intent. If Atlas is a probe, does it mean to threaten us? Or is it simply indifferent, executing ancient instructions without awareness of the consequences? Either way, perihelion stands as the inflection point. After late November 2025, Atlas's path will be fixed. Whatever it's meant to do, signal, maneuver, deploy, or simply drift, it will be set in motion then. We'll watch from Earth, our instruments straining for clarity, hoping the strangeness collapses into ordinary cometary behavior, but bracing for the possibility that it doesn't. And that brings us to the crucial question: how do we tell the difference between a comet and a weapon? The answer, as always, lies in comparison, patterns, precedents, and outliers across decades of skywatching. And that is exactly where we're headed next. Part 10. Control Case. Swan versus Atlas. The smoking gun. Science advances through comparison. You don't establish that something is extraordinary by examining it in isolation. You prove it by contrasting it with the standard, demonstrating that the differences go beyond normal variation. This fundamental principle is why control groups are essential in experiments. Similarly, astronomers catalog thousands of objects to build statistical baselines of what normal looks like. When something strays significantly from this baseline, it demands investigation. Comet C20-25R2, known as Comet Swan, serves as the perfect control case for Atlas. Both are comets, both were active in 2025, both observed by similar instruments, but their behaviors couldn't be more different. Comet Swan entered the inner solar system in early 2025, discovered through wide-field images from the Solar and Heliospheric Observatory. It was a crotazar, a fragment from a larger comet that had shattered centuries ago, now following a path that would bring it within just a few million miles of the Sun's surface. Astronomers anticipated spectacular activity as Swan neared perihelion on March 20, 2025, and their expectations were met in full. Swan developed a colossal coma, a glowing cloud of gas and dust visible even through backyard telescopes. Its tail stretched millions of miles, a dazzling streamer of ionized gas, driven by the solar wind, captured in stunning photographs by amateur astronomers around the globe. The European Space Agency's SOHO spacecraft captured Swan's final plunge toward the Sun, observing it brighten dramatically, partially vaporize and either fragment or survive as a much smaller remnant. Swan embodied everything a comet should be: bright, active, predictable, and beautiful. Now consider Atlas. Discovered in 2024, Atlas followed a radically different path, entering the solar system from interstellar space rather than the Oort cloud like Swan. Its orbit was hyperbolic, unbound, meaning that after perihelion it would leave the solar system forever unless its velocity changed. This alone makes Atlas intriguing, but not unprecedented. We've seen other interstellar visitors like Oumuamua in 2017 and Borisov in 2019. What truly sets Atlas apart is its unusual activity profile. Throughout most of its approach, Atlas remained faint and barely detectable, exhibiting minimal cometary features. No bright coma, no obvious tail, just a dim point of light that brightened sluggishly as it neared the Sun. Then, in mid-September 2025, at 2.1 AU, hydrogen cyanide emission suddenly surged, not water vapor or carbon monoxide, which are more common cometary volatiles. Hydrogen cyanide, a less abundant and far more volatile compound, appeared abruptly. Compare the images. Swan's coma glows radiant and symmetrical, expanding uniformly as gas and dust lift off the nucleus. Atlas's coma, in stark contrast, is faint and asymmetric, with jet-like features suggesting localized emissions rather than smooth, uniform sublimation. Swan's tail is textbook perfect, streaming away from the Sun in a graceful arc, shaped precisely by radiation pressure and the solar wind. Atlas's tail is erratic, sometimes visible, sometimes completely absent, and occasionally even pointing toward the Sun, defying basic physics. Show these images to a planetary scientist without context, and they'd instantly identify Swan as a comet. Atlas, however, would raise questions. What is this object? Why does it behave this way? Is there an error in the data? The contrast in brightness is just as striking. Swan reached naked-eye visibility, shining at magnitude 3 or 4 at its peak, easily seen from dark skies. Atlas, by comparison, remained faint, magnitude 10 to 12, detectable only with decent amateur telescopes. This matters because brightness correlates directly with activity. A bright comet is actively sublimating, releasing massive amounts of gas and dust. A faint comet is relatively dormant. Yet Atlas is releasing hydrogen cyanide at prodigious rates around 4x 1025 molecules per second. So where's the dust? Where's the reflected sunlight that should make it glow brighter? Either Atlas's nucleus is unusually dark, absorbing rather than reflecting light, or its emissions are almost entirely gaseous, lacking the dust component that makes comets shine. Both scenarios are highly unusual. Here's the rhetorical punch. If Atlas and Swan were both natural comets, products of the same physical processes, they should exhibit similar behaviors scaled to their sizes and compositions. But they don't. Swan behaves exactly as centuries of cometary science predict. Atlas, however, acts like an outlier, an anomaly, an object that seems to follow different rules. You could argue Atlas is just a weird comet, that natural variation is broad, that our understanding of cometary physics is incomplete, and you'd have a valid point. But when you add the hydrogen cyanide spike, the anti-tail, the spacecraft blackouts, the data delays the sudden activation. At a precise distance, the accumulation of anomalies begins to tip the scales. At some point, invoking natural variation becomes less parsimonious than entertaining alternative explanations. And here's the alternative: that Atlas is artificial engineered, following a programmed sequence, explains the data far more elegantly. We'll revisit this comparison as Atlas approaches perihelion in late November. If Atlas suddenly brightens, develops a massive coma and tail, and behaves like Swan did, then perhaps the anomalies were just early-stage quirks that resolved into normal cometary activity. But if Atlas continues its erratic behavior, if hydrogen cyanide emissions intensify without matching increases in brightness, if the tail remains anomalous, and if new unexplained features emerge, then the case for artificiality grows stronger. This isn't the end of the investigation, it's the midpoint. We're watching in real time as the data accumulates, as Atlas slowly reveals itself, as the answer becomes impossible to ignore. And while we watch Atlas, other developments in science and technology are quietly reshaping what we think is possible. The world of 2025 is stranger than it was even 5 years ago. Let's zoom out and see what else is unfolding, because context matters. The universe doesn't operate in isolation, and neither does Atlas. Part 11. AI predicts the collapse of fusion startups. In October 2025, a research team at MIT unveiled a sobering analysis powered by machine learning models to forecast the viability of private fusion energy companies. Fusion, the process that powers stars, has been humanity's dream for nearly a century. Achieve controlled fusion on Earth, and you unlock effectively limitless clean energy. Deuterium fuel is extractable from seawater. Helium byproducts are non-reactive. No carbon emissions, no meltdown risks, just abundant power. For decades, fusion remained perpetually 30 years away, a running joke in physics departments. But in the 2020s, private companies entered the race with renewed hope. Commonwealth Fusion Systems, TAE Technologies, Helion Energy, and dozens of other startups backed by billionaires and venture capital have all promised commercial fusion by the 2030s. But the MIT study poured cold water on that optimism, using financial modeling, technical assessments, and historical data on energy technology deployment. The AI predicted that roughly 70% of these companies would fail by 2030, unable to overcome engineering hurdles or secure sustained funding. Why does this matter for Atlas? Because energy is power, both literally and politically. Control over energy resources determines which nations dominate, which economies thrive, and which populations live comfortably versus desperately. If fusion succeeds, it decentralizes energy. Any country with technical expertise could build reactors ending dependence on fossil fuels, uranium, and geopolitical choke points. But if fusion fails, if the startups collapse, if the dream dies again, then existing power structures endure. Oil-producing nations retain their influence. Nuclear power, with its waste and proliferation concerns, stays relevant. Renewable energy, with its intermittency challenges, continues to demand massive grid infrastructure. The status quo endures. And in that context, an external threat like Atlas becomes useful. Imagine a scenario where governments need to justify enormous expenditures, need to consolidate control, need to rally populations around a common enemy. An alien probe, a cosmic threat, a weapon drifting toward Earth, that's the perfect crisis. Consider the timing fusion companies struggle in 2025. AI models predict most will fail by 2030. Atlas appears in 2024, activates in 2025, and approaches perihelion in late 2025. If Atlas escalates, if it becomes a publicized threat, governments could declare a planetary emergency. Resources get redirected. Civilian fusion projects get nationalized or defunded. Military priorities take center stage. Space defense becomes the justification for budgets dwarfing anything seen before. And conveniently, the private fusion sector, which might have democratized energy, collapses under lack of investment. I'm not claiming this is a coordinated plan, but systems don't need conspiracies to produce conspiratorial outcomes. Incentives align. Crises get exploited. The AI's prediction of fusion startup failure might be accurate on its own terms, but it also describes a window of vulnerability. A period when humanity's energy future is uncertain, when fear could drive policy more than optimism. Let's add another layer. If Atlas is artificial, if it was sent by an advanced civilization, what would they know about us? If they've been observing Earth for decades or even centuries, they'd have a deep understanding of our energy dilemmas. They'd see our reliance on combustion, our slow progress toward fusion, our geopolitical fragmentation. An intelligence looking to destabilize or manipulate humanity might time their intervention for maximum impact, arriving when we're least prepared, when our technological optimism is crumbling, when internal divisions are at their sharpest. Atlas's arrival in the mid-2020s, during this period of fusion uncertainty, rising global tensions, and increasing climate and economic pressures, is either an extraordinary coincidence or a meticulously calculated move. And I'm not inclined to believe in coincidences anymore. This isn't just about Atlas. It's about recognizing that existential threats don't occur in a vacuum. They intersect with existing crises, amplify them, and exploit vulnerabilities. Whether Atlas is a probe, a weapon, or a natural object, we've misunderstood it. Its impact on human civilization will depend on context, and that context in 2025 is one of an energy sector teetering on the edge, geopolitical instability, and a population growing increasingly distrustful of institutions. Atlas could be the spark in a very dry forest. But energy isn't the only frontier where things are getting strange. Let's shift our gaze outward to the dark spaces between stars, where invisible monsters drift silently, waiting to be discovered. Part 12. The Milky Way's Rogue Black Hole Update. Black holes are the universe's ultimate predators, gravity so intense that not even light can escape. Space-time is warped into a one-way trap where the normal rules of causality break down at the event horizon. Most black holes we know fall into two categories. Stellar mass remnants, 10 to 100 times the sun's mass formed when massive stars collapse in spectacular supernova, and supermassive monsters, millions to billions of solar masses, lurking at galactic centers like cosmic engines of destruction. Both types announce their presence by interacting violently with their surroundings. Stellar mass black holes often exist in binary systems, pulling gas from companion stars through tidal forces, heating that gas to millions of degrees via friction and compression, causing it to glow brilliantly in X-rays. Supermassive black holes power quasars, devouring entire solar systems' worth of material in their accretion disks, broadcasting across the electromagnetic spectrum with luminosities that outshine entire galaxies. But what about isolated black holes, those drifting alone through interstellar space, neither feeding nor glowing invisible, except for their gravitational influence? How many of these exist? We don't know. We fundamentally cannot see them directly. They emit nothing, reflect nothing, appearing as absolute voids against the cosmic background. We can detect these elusive objects only when they drift across the line of sight of a background star, momentarily amplifying its light through gravitational microlensing, a remarkable phenomenon predicted by Einstein, where massive bodies warp space-time itself, acting as a natural lens that sharpens and brightens the light from more distant sources. This effect is faint, fleeting, and demands extraordinary fortune to witness. In September 2025, a team analyzing data from the Hubble Space Telescope, combined with ground-based surveys, announced the discovery of a rogue black hole roughly 12 times the mass of our Sun, silently wandering through the Milky Way, about 4,000 light-years away from Earth. The detection arose from a micro-lensing event that unfolded over several months, during which the light from a distant star brightened and dimmed in a pattern perfectly matching a massive dark object passing between us and the star. By carefully analyzing the light curve, the detailed pattern of brightening and dimming over time, along with the event's duration and the extent of the brightening, astronomers precisely calculated the lens's mass and velocity. 12 solar masses traveling at approximately 100,000 km relative to the surrounding stars. This is a true rogue. A black hole violently ejected from its birthplace, likely due to an asymmetric supernova explosion that delivered a powerful gravitational kick. Now it roams the galaxy unseen, detectable only when a rare geometric alignment brings it into view. The mathematical rigor behind identifying this object was immense, as researchers had to sift through countless variables to isolate the unmistakable signature of a black hole. Stellar variability, instrumental noise, atmospheric distortion, each a potential source of confusion. To overcome these, the team cross-checked observations from multiple telescopes, confirmed the event through independent data sets, and rigorously modeled various scenarios to rule out alternatives. A planet wouldn't create the exact light curve observed. A dim star would produce different chromatic signatures. Only a black hole matched the data perfectly. This achievement embodies years of relentless effort, powered by automated surveys monitoring millions of stars simultaneously, all waiting patiently for the faint, unmistakable signal of gravitational lensing to emerge. Yet this discovery brings a troubling question to the fore. If we've detected one rogue black hole through microlensing, how many more remain unseen? Microlensing demands a near-perfect alignment. The black hole, the background star, and Earth must line up within an extraordinarily tiny angular window, often less than a millisecond of arc, smaller than the angle needed to resolve a dime from 1,000 miles away. The chance of any star being lensed at any given moment is vanishingly small, so detecting even a single rogue black hole suggests a vastly larger population lurking unseen. Some estimates propose that tens of millions of stellar mass black holes drift through the Milky Way, most densely packed in the galactic disk, where star formation is most active, with some scattered in the halo entirely invisible unless they happen to lens a star or capture matter to accrete. We're swimming in a sea of invisible gravitational traps, only aware of them when we happen to stumble into their narrow detection cones. Consider the scale. Our galaxy spans roughly 100,000 light-years and contains hundreds of billions of stars. If tens of millions of black holes are scattered throughout this immense volume, the average distance between them could be just a few dozen light-years, close enough that stellar mass black holes pose a serious hazard to any interstellar voyage. A spacecraft traveling between stars would need to map these invisible dangers, find ways to detect them, and skillfully navigate around them. And if we're only now beginning to glimpse them through microlensing, how might an advanced interstellar civilization cope with this challenge? They would require detection technologies far beyond anything we currently possess. Perhaps future gravitational wave sensors, sensitive enough to detect the subtle ripples in space-time caused by isolated black holes, or even exotic physics we have yet to uncover, will help us map these hidden giants. This idea connects intriguingly to Atlas. We assume we have a solid understanding of what's in our own solar system. Decades of systematic surveys have cataloged asteroids, comets, and Kuiper Belt objects. We track near-Earth objects that might pose collision risks, maintaining extensive databases of potentially hazardous asteroids. We believe we have a reasonable census of our cosmic neighborhood. But if the Milky Way teems with invisible black holes that we're only now starting to detect, what else might be lurking unseen, dark, non-emitting objects that defy our detection methods? Stealthy probes minimizing electromagnetic signatures, or even artificial structures cleverly camouflaged within natural debris. The rogue black hole discovery is a stark reminder that absence of evidence is not evidence of absence. Just because we haven't seen something doesn't mean it's not there. It might simply be invisible to our current tools, hidden in observational blind spots we haven't even realized exist. And to be clear, I'm not suggesting Atlas is a black hole. It's clearly emitting light gas detectable by telescopes operating across multiple wavelengths. But the principle still holds. Atlas appeared suddenly in our detection systems, initially classified as a comet, because that's exactly what our survey telescopes are optimized to find. Had it remained dormant, had it not activated its hydrogen cyanide emissions, when it did, it might have slipped through the inner solar system unnoticed, just another faint asteroid on a hyperbolic trajectory too small and dark to trigger our automated detection algorithms. The fact that we're tracking it now is almost accidental, dependent entirely on its activation, coinciding with a time and place where our instruments could catch the activity. How many other Atlas-like objects have silently passed through the inner solar system unseen throughout human history? How many are out there now, dormant and invisible, waiting only to reveal themselves when they choose or when we develop detection methods sensitive enough to uncover them? The rogue black hole discovery underscores a profound truth about cosmic indifference. That 12 solar mass black hole doesn't care about Earth. It's not targeting us. It's simply drifting, governed by orbital mechanics, a byproduct of astrophysical processes billions of years in the making. If its path happened to cross Earth's orbit at the exact moment we occupy that space, our fate would be sealed. Not from malice, not from intent, but from sheer random cosmic bad luck. Atlas might be no different. It may not be a weapon aimed specifically at humanity. It could be a probe following a pre-programmed route, executing survey protocols devised millennia ago, and we just happen to be in its way. Intent means nothing if the outcome is disastrous. A bullet doesn't need to hate you to kill you. Recognizing that the universe doesn't revolve around humanity, that countless objects and entities follow their own courses, utterly indifferent to our survival, is both humbling and terrifying. It forces us to confront the truth of our cosmic insignificance. We are not the center of creation, not the pinnacle of cosmic evolution, but merely one species on one planet, adrift in a vast universe, potentially in the path of forces and intelligences we scarcely comprehend. This understanding should shape how we think about Atlas, about the prospect of extraterrestrial contact, and about our fragile position within the cosmos. It's a theme that resonates across other recent discoveries, especially in physics, where the boundaries of our understanding blur, and we begin to see that reality itself may operate according to principles far deeper than our current grasp, with quantum mechanics and relativity offering only fleeting glimpses of an underlying structure we've barely begun to perceive. Part 13. Quantum time crystals achieve their first practical demonstration. Quantum mechanics is undeniably strange, not an exaggeration, but a precise description. Particles exist in superposition, occupying multiple states at once until observed. Entangled particles maintain correlations across vast distances, instantly defying classical notions of locality. The uncertainty principle imposes fundamental limits on what we can know precisely. Now, in 2025, physicists have successfully demonstrated stable time crystals, a phase of matter so bizarre that even seasoned quantum theorists once doubted their existence. Unlike ordinary crystals such as salt or diamond, which feature atoms arranged in repeating spatial patterns, a time crystal exhibits periodic behavior in time itself, cycling endlessly without energy loss. Shake a regular crystal, and it quickly returns to equilibrium, settling back into a stable state. But a time crystal is fundamentally different. It oscillates endlessly, cycling through a series of states without any external energy input, never settling into equilibrium. Its motion, which occurs without energy cost, represents a form of temporal order that seems to challenge thermodynamics but doesn't, because time crystals exist in carefully engineered, non-equilibrium quantum systems that harness subtle quantum effects. At first glance, the concept sounds impossible. After all, perpetual motion machines have been dismissed as impossible for centuries, barred by the laws of thermodynamics. Energy can't be created from nothing, and entropy always increases in closed systems. Yet time crystals thread a delicate needle through these restrictions by existing as open quantum systems, where a continuous flow of energy maintains a special stable oscillation, indefinitely never equilibrium, but a persistent repeating cycle. Think of it like a quantum version of a planet orbiting a star. Once the motion is established, it continues without extra energy input, not generating energy from nothing, but sustained by the system's initial conditions that allow this perpetual cycling to endure. In March 2025, a team at Google's Quantum AI Lab announced they had successfully created a time crystal within their Sycamore quantum processor, sustaining coherence for over 100 oscillation cycles, an achievement orders of magnitude longer than previous attempts. This breakthrough demanded extraordinary precision, manipulating individual qubits with laser pulses timed to femtosecond accuracy. The researchers showed that the system oscillated at exactly half the driving frequency, a hallmark of time crystalline behavior. Crucially, this oscillation persisted even when they introduced deliberate perturbations aimed at disrupting it. The time crystal demonstrated remarkable robustness, self-correcting, and maintaining its temporal pattern under conditions that would typically destroy conventional quantum states. Then, in August 2025, researchers at MIT revealed a room-temperature time crystal created from a lattice of nitrogen vacancy centers in Diamond System, with promising potential for scalable practical applications. This breakthrough eliminated the need for near absolute zero temperatures and exotic superconducting hardware, bringing time crystals out of specialized laboratory environments and into conditions where real-world applications become achievable. The diamond lattice approach leverages defects in the crystal structure, specifically places where nitrogen atoms replace carbon atoms, forming nitrogen vacancy centers that act as quantum systems remaining coherent at room temperature. These nitrogen vacancy centers can be precisely controlled using microwaves and lasers, driving them into time crystalline states that oscillate with extraordinary stability. These aren't just theoretical curiosities confined to physics journals. Time crystals have the potential to revolutionize quantum computing by providing stable qubits that resist decoherence, the primary hurdle preventing quantum computers from scaling to practical sizes. Beyond computing, they could enable ultra-precise sensors, clocks that never drift beyond fundamental quantum limits, and memory storage that never degrades, since information would be encoded in temporal patterns rather than fragile spatial states. And speculatively, they might form the foundation for technologies we can't yet conceive, exploiting the structure of time itself in ways classical physics forbids. Some theoretical studies suggest that time crystals could enable new quantum communication protocols, detect gravitational waves with unprecedented sensitivity, or even probe the fundamental nature of time. Why does this matter for Atlas? Because if human scientists in 2025 are already demonstrating time crystals, what might an advanced extraterrestrial civilization have accomplished centuries or millennia earlier if Atlas is artificial? Its internal systems might operate on principles of physics far beyond our current mastery. Time crystalline cores could serve as perfectly stable energy reservoirs, maintain coherent quantum states for computation or communication, or even manipulate space-time in ways so subtle we have no framework to interpret them. From an external perspective, we might see nothing unusual at all. Yet beneath the surface could lie technologies that redefine our understanding of matter, energy, and time itself. We'd need to dismantle it, analyze its materials at atomic resolution, probe its internal architecture, and uncover its operating principles through direct examination. But from a distance, all we can observe are anomalies, behaviors that defy natural models, emissions that don't align with expected thermal or chemical processes, trajectories that display a precision exceeding what gravitational dynamics alone could explain. Consider the hydrogen cyanide emission. We interpret it as sublimation, ice heating, and vaporizing as Atlas nears the sun. But what if it isn't sublimation at all? What if it's the byproduct of a time crystalline energy system, an artifact of quantum processes operating within its core? In that case, the hydrogen cyanide wouldn't be the result of solar heating, but a form of exhaust, a waste product of whatever mechanism sustains Atlas's activity. The observed emission pattern, the sudden onset, the sustained and controlled output might correspond not to natural outgassing, but to the activation cycle of a quantum system coming online. This explains why the emission didn't correlate predictably with distance from the sun, why it appeared abruptly instead of gradually increasing, as thermal models would suggest. It wasn't driven by heat, it was technologically driven. And if time crystal technology is involved, the system could operate with extraordinary efficiency, minimal energy loss, and sustained performance over timescales that render conventional power sources almost primitive by comparison. Consider the energy budget: chemical reactions. Store energy in molecular bonds, releasing it through combustion or electrochemistry. Nuclear reactions tap the binding energies within atomic nuclei. Both are one-way processes. Once the fuel is spent, it's gone. Time crystals, in contrast, maintain their oscillation indefinitely, once established, requiring only minimal energy input to preserve coherence against environmental noise. For a probe journeying between stars, this difference could mean the gap between a functional lifetime measured in decades and one spanning millions of years. A time crystalline power system wouldn't generate thrust directly. Its true value lies in delivering stable, long-lasting energy to sustain vital onboard systems. You'd still need propellant for propulsion, but such a system could power computers, sensors, communication arrays, and control mechanisms essentially indefinitely. Imagine Atlas could have launched when humans were still living in caves, and yet remain fully operational today. I want to be clear, this is speculation. We have no direct evidence that Atlas contains time crystals or any form of exotic quantum technology. But considering these possibilities broadens how we think about what such an object might be and what it could do. But the demonstration of time crystals in 2025 expands the boundary of plausibility. It forces us to rethink what qualifies as technologically achievable. Only 5 years ago, time crystals were theoretical curiosities, mathematical constructs that many physicists suspected might violate fundamental laws. Today, they've moved from equations to laboratory reality, with practical applications now on the horizon. Extrapolate that rate of progress across centuries, across a civilization with knowledge and resources far surpassing ours, and the technological gulf becomes almost unimaginable. Atlas could stand in relation to our spacecraft, the way a smartphone stands to a chipped flint blade. We can tell it's functioning. We can observe its outputs. But truly understanding how it works, grasping the underlying principles, might lie completely outside our current conceptual framework. And there's another implication worth noting. Time crystals challenge our most fundamental assumptions about entropy, about the arrow of time itself, about how systems naturally drift toward disorder and decay. They suggest that under specific quantum conditions, behaviors resembling perpetual motion may be possible within the strict bounds of physics rather than in defiance of them. If a civilization mastered such principles, it could construct machines capable of operating indefinitely without the need for refueling. Probes could drift through interstellar space for millions of years, maintaining full functionality, silently awaiting the right activation trigger. Atlas's apparent dormancy during its long voyage followed by its sudden coordinated activation fits that profile almost exactly. A time crystalline power core could keep essential systems alive indefinitely, just enough processing to monitor sensors, track position, and calculate trajectory, then scale up to full operational capacity when it detects specific cues, such as the proximity of a star or the electromagnetic signatures of a technological civilization. We're interpreting Atlas through the lens of conventional physics, constrained by engineering assumptions rooted in our narrow experience with spaceflight. But Atlas may operate according to principles we've only begun to glimpse, principles emerging now tentatively from the frontiers of quantum research in our most advanced laboratories. The fact that we're uncovering these principles at all suggests they're not impossibly exotic, just advanced. They represent a higher rung on the same technological ladder, one that any sufficiently persistent scientific civilization could eventually ascend. And if we're already beginning to approach these ideas, what else might lie within our future grasp? What technologies are we developing now that could have extraterrestrial analogs? What capabilities might we achieve in the next century that would look like magic from today's perspective? As it happens, some of our current research already points in that direction. We're developing stealth systems technologies designed to manipulate electromagnetic, acoustic, and even gravitational signatures that sound suspiciously relevant to how an object like Atlas might conceal itself. Part 14. China's Hypersonic Plasma Shield Patent. In early October 2025, defense analysts uncovered a patent filing from a Chinese aerospace research institute detailing a plasma-based shielding system designed for hypersonic vehicles. Surprisingly, the patent details were not classified an unusual move that suggests either a deliberate show of force aimed at rivals or a possible administrative slip that exposed sensitive technology to the public. Here's how the system works. As a hypersonic vehicle speeds through the atmosphere at Mach 5, or higher aerodynamic friction, heats the surrounding air to plasma temperatures reaching thousands of degrees, forming a glowing sheath around the craft. This plasma layer naturally disrupts radar signals, rendering the vehicle significantly harder to detect and track. However, it also triggers communication blackouts, disrupts thermal imaging, and introduces structural heating challenges that engineers have battled with for decades. The Chinese patent outlines the use of electromagnetic fields to manipulate and stabilize this plasma sheath, transforming a persistent problem into a strategic advantage. Magnetic coils produce fields that guide the plasma into precise formations, creating dense ionization zones that actively deflect incoming electromagnetic radiation, essentially crafting a force field against radar and directed energy weapons. The patent's technical details propose a multi-layered strategy with varied field geometries tailored to counter different threat profiles. When faced with radar, the plasma generates a constantly shifting diffuse surface that unpredictably scatters incoming waves. Against laser weapons, the ionized particles absorb and disperse the concentrated light before it can amass enough energy to damage the vehicle's hull. It's a masterful application of physics weaponized for defense. The patent takes it even further, indicating that the system could be deployed in space, not just within an atmosphere. By placing similar magnetic field generators on a spacecraft, releasing ionizable gases like xenon or argon from onboard reservoirs, and creating an artificial plasma bubble in the surrounding space, the defense mechanism would function seamlessly in the vacuum of space. This plasma bubble would scatter radar-absorbed laser strikes by ionizing the energy before the beam ever reaches the hull, and could even disrupt particle beams or electromagnetic pulses. While it's not quite the starship shields we've seen in science fiction, it's a formidable defense against electronic warfare and directed energy weapons. It doesn't stop physical projectiles, but in the realm of high-tech threats, it proves remarkably effective. The patent also suggests the technology is mature enough for testing and may already be in use on experimental platforms. The potential applications for space combat satellite defense and even asteroid or comet interception missions are nothing short of revolutionary. But there's an unsettling implication that no one in the defense community wants to voice. If China is working on plasma shields for spacecraft, what's already out there might have them too. Picture this atlas shielded by a thin layer of ionized gas sustained by internal magnetic field generators. This plasma layer would make it significantly harder to identify or analyze spectroscopically, from a distance shrouding it in an almost impenetrable veil of stealth. Light passing through plasma is scattered, absorbed, and re-emitted at different wavelengths, blurring spectral lines and masking emission features. What we interpret as faint, irregular cometary activity could in fact be a form of advanced stealth technology, a plasma shield that modulates the amount of electromagnetic radiation that escapes. This would make Atlas appear dimmer and more erratic than it truly is, creating a deceptive image that hides its true characteristics. The hydrogen cyanide we've detected might only be the small fraction of emissions that manage to leak through the shield, while the majority are ionized and absorbed by the system. This could explain why Atlas appears less bright than expected, based on its gas production rate. It's not that Atlas is unusually dark, it's that we're observing it through a veil, an intentionally crafted obscuration layer, designed to control the flow of information reaching our telescopes. The Chinese patent also highlights the potential of plasma shields to protect against hypervelocity impacts, tiny particles traveling at orbital speeds. In the vacuum of space, even minuscule debris can penetrate metal at these extreme velocities, making such a shield an essential defense for spacecraft against seemingly insignificant but potentially catastrophic threats. A plasma shield doesn't obliterate incoming debris, but it electrifies their surface layers, subtly nudging the particles off course or stripping away their outer shells to reduce their effective mass. For a probe like Atlas journeying through the vast emptiness of interstellar space over centuries or even millennia, micrometeorite impacts pose a relentless threat. Over thousands of years, these tiny collisions would relentlessly erode even the toughest materials, sandblasting solar panels, scarring optical sensors, and potentially undermining the probe's structural core. A plasma shield would serve as formidable armor safeguarding Atlas through an onslaught of cosmic impacts. As the probe nears a star like our Sun, it could intensify this shield, fortifying itself against the heightened barrage of solar wind and radiation. From afar, we'd observe this as a surge in plasma emissions, mistaking it for cometary activity, never suspecting it's actually cutting-edge defensive technology kicking into high gear to counter environmental hazards. This system would operate autonomously, dynamically adjusting shield strength based on real-time sensor data tracking, particle density, and radiation levels. Now let's dive into the shadows and entertain a conspiratorial twist for a moment. The timing of this Chinese patent, filed in October 2025, raises eyebrows. Just a month earlier, in September 2025, Atlas activated its hydrogen cyanide emissions. Then, within weeks, China publicly submits a patent for plasma shielding technology that eerily explains several of Atlas's observed anomalies. Coincidence, perhaps? Or perhaps someone in Chinese aerospace monitoring Atlas via military telescopes with superior resolution to civilian ones spotted telltale features hinting at plasma shielding and reverse-engineered the concept from there. Or maybe they'd been developing it independently all along, only to see Atlas's behavior confirm their approach. Either way, this patent filing sends a clear message to rival nations. We know what's out there. We grasp the technology, and we're already crafting countermeasures. It's a geopolitical signal cleverly disguised as technical documentation. And it hints that classified observations of Atlas could dwarf anything available to the public. Think about the capabilities of military-grade space surveillance systems. Civilian telescopes capture brightness trajectory and spectral signatures. Military setups go further, incorporating infrared monitoring, electromagnetic signature analysis, and even gravitational microlensing effects. If Atlas is producing magnetic fields powerful enough to confine plasma-sensitive magnetometers would pick them up. If it's emitting ionizable gas, spectroscopic analysis could uncover isotopic ratios that defy natural cometary processes. Military analysts might have flagged these anomalies months earlier, distilled them into secret reports, and kicked off countermeasures, all without a whisper to the public. The Chinese patent could be a glimpse into that shadowy technological arms race, a bold maneuver to assert dominance and showcase unparalleled capability. But consider a far more chilling possibility. What if plasma shield technology isn't merely a defensive tool? What if it's a weapon, a plasma bubble supercharged by precisely controlled electromagnetic fields could transform into a devastating directed energy weapon? By shaping those fields to channel the plasma into a focused beam, you'd unleash a scorching jet capable of slicing through materials, frying electronics, or even targeting biological tissue with lethal precision. If Atlas possesses such a system, the hydrogen cyanide cloud might be a mere distraction, a secondary threat masking the true danger, an electromagnetic plasma weapon designed to activate at perihelion when solar energy surges to its peak. This could unleash a catastrophic energy burst aimed at Earth or our satellites, catching us utterly defenseless. Our current detection systems are blind to this threat. We're scanning for kinetic impacts, gravitational anomalies, or overt weaponry, not subtle electromagnetic buildups or magnetic field distortions around Atlas. We assume it's just a comet, and comets don't wield weapons. But this one might. The physics aligns at perihelion. The intense solar flux delivers maximum power, fueling a weapon we're not prepared to counter. Atlas could harness its capacitor banks, ramping up its magnetic field generators to peak intensity, while releasing a massive surge of ionizable gas. These magnetic fields would constrict and propel the plasma, forging a tightly focused beam with temperatures surpassing the sun's surface. Aimed at Earth, this weapon wouldn't need to breach the atmosphere. It could zero in on satellites, communication grids, and GPS networks, unleashing a single devastating burst capable of incapacitating hundreds of satellites in an instant, plunging our tech-dependent civilization into chaos. The plasma's rapid dissipation post-discharge would leave little trace, making forensic analysis a nightmare. We might never confirm whether it was a calculated strike or a bizarre natural event. The ongoing race to develop plasma shield technology, evident in China and likely pursued in secrecy by the United States and other nations, sends a clear, urgent signal about the stakes involved. We're stepping into an era where space is a battleground, where stealth and electronic warfare stretch far beyond Earth's atmosphere, and where the line between civilian and military space assets grows dangerously indistinct. In this high-stakes arena, an enigma like Atlas emerges as a critical test. How do we shield ourselves from something we barely comprehend? How do we probe its true nature without triggering it, if it's even capable of being triggered? And how do we forge a unified global response when nations are locked in a fierce race for technological supremacy? These aren't abstract hypotheticals. They're urgent, real-world challenges that space agencies and militaries are wrestling with in hushed, classified briefings. Meanwhile, Atlas barrels closer to perihelion, inching toward whatever purpose it's been designed to fulfill. But secrets, classified observations, concealed data have a way of unraveling. Technology is rapidly advancing, unveiling what human eyes cannot detect. And that's where this saga takes its most bizarre and unsettling twist yet. Part 15. The unblinking AI astronomer rewriting our cosmic story. In the remote, windswept expanse of Chile's Atacama Desert, perched at 2,600 meters where the air is so thin, it sharpens the stars into pinpricks of crystalline light. A groundbreaking observatory came fully online in July 2025. This is no cathedral of science adorned with a name to stir the soul like Hubble or James Webb. Instead, it bears the utilitarian title of the Autonomous Transient Detection Array, ATDA. Yet within this unassuming name lies a revolution, a seismic shift in how humanity gazes into the abyss of the cosmos. Spanning acres of arid terrain, ATDA's grid of 40 modest 40-centimeter telescopes may seem humble, but together they form a tireless, unerring sentinel of the heavens, a machine-driven eye that never sleeps, never blinks, and never wavers in its quest for the unknown. Each telescope on its own is unremarkable, unlikely to quicken the pulse of a seasoned astronomer accustomed to the grandeur of monolithic observatories. But united through a web of fiber optic cables feeding into a central AI processing cluster, these 40 instruments transcend their individual limits to create something extraordinary. The ATDA is not just an observatory. It is a paradigm shift, a fully autonomous system that operates 24 hours a day every night without human intervention. It selects its targets with surgical precision, captures images with relentless efficiency, analyzes data in real time, and flags cosmic anomalies for immediate follow-up. This is the future of astronomy, a machine that outpaces human capability, unbound by fatigue, distraction, or the sluggish pace of bureaucratic approval. The AI powering ATDA is a marvel in itself, forged from decades of astronomical archives, trained to recognize the familiar rhythms of the universe. The steady glow of stars, the majestic spirals of galaxies, the explosive brilliance of supernovae, the predictable waltz of asteroids, and the subtle flickering of variable stars. Its purpose, however, is not to catalog the known, but to hunt the unknown transient events that defy the patterns of the cosmos. A star that flares without warning, brightening or dimming in ways that defy explanation. An object carving an impossible trajectory through the void. A spectral signature that matches no known element or molecule in our cosmic library. When ATDA detects such an anomaly, it doesn't wait for a human to ponder the data days or weeks later. It acts instantly, redirecting multiple telescopes to the target, capturing high-resolution multi-wavelength observations and constructing a detailed time series dataset within minutes. If the anomaly persists, ATDA escalates, sending alerts to observatories worldwide, coordinating follow-up observations and compiling comprehensive reports, all at a speed no human-led system could hope to match. This AI is tireless, immune to the frailties of human attention. It never grows weary, never loses focus, and never pauses to seek permission to shift its gaze. In its first 3 months of operation, ATDA identified 17 transient events that had slipped past other surveys. Most were familiar phenomena, known objects observed from unusual angles or at unexpected times. But 3 stood apart, unclassified and enigmatic, challenging the very foundations of our understanding of the universe. The first was a star previously catalogued as unremarkable that erupted in a blaze of light, its intensity surging by a factor of 50 in just 6 hours, before fading back to its baseline over 2 days. No known stellar mechanism explains this bizarre light curve. It wasn't a supernova, there were no spectral lines indicating elemental fusion. It wasn't an eclipsing binary, the timing and symmetry were all wrong. The star simply flared, dimmed, and returned to normal, leaving astronomers grasping at straws. ATDA flagged it as anomalous, archived every scrap of data, and continues to monitor the star, waiting for it to reveal its secret again. Somewhere in its vast database, that star's behavior is preserved, a cosmic question mark etched in code. The second anomaly was even stranger, an object in the asteroid belt, moving with an erratic trajectory that defied the laws of gravitational motion. For several nights, ATDA tracked its path, calculating that it followed a non-Keplerian orbit, one not governed solely by the sun's gravitational pull. Something was perturbing its course, but what? An undiscovered asteroid passing at precisely the right moment seemed astronomically unlikely. The alternative, that the object was maneuvering under its own power, was almost too provocative to consider. ATDA flagged it for human review, but by the time astronomers mobilized, the object had slipped into the dense stellar clutter of the Milky Way's galactic plane, lost in a sea of background stars. It remains untracked, a ghost in the data, its true nature tantalizingly out of reach. The third event, still under intense investigation, is perhaps the most unsettling. ATDA detected a spectral line in a distant galaxy that corresponds to no known element or molecule. It could be an instrumental artifact, a glitch in the spectrograph, but the signal appeared consistently across multiple exposures captured by different telescopes in the array, making a glitch unlikely. If real, this spectral line suggests either a previously unobserved quantum transition, or more radically, an emission from a substance that doesn't exist in our current periodic table. The implications are profound, hinting at physics beyond our grasp, a glimpse of something fundamentally new in the universe's vast repertoire. ATDA is more than a tool. It is a new way of seeing, a machine intelligence that sifts through the ordinary to spotlight the extraordinary. It operates free from the biases, assumptions, and limitations that shape human observation. This raises a chilling question. What if the universe has been trying to communicate with us for centuries, sending signals or deploying probes designed not for human eyes, but for machines? What if an advanced civilization assumes that any technological species would eventually develop AI observers, capable of recognizing patterns our organic minds are blind to. Humans seek the familiar stars, planets, comets, galaxies, our pattern recognition honed by evolution and culture. But an AI trained solely on raw data unbound by preconceptions might see what we've missed for millennia. Consider the non-Keplerian asteroid ATDA flagged. A human astronomer might dismiss its odd trajectory as outgassing the Yarkovsky effect, or observational error explanations rooted in our assumptions about natural phenomena. But an AI programmed to detect deviations from expected motion would flag it instantly, unswayed by human skepticism. Could ATDA be uncovering a hidden population of artificial objects in our solar system, flagged as anomalies, but buried in databases waiting for human review? The bottleneck is us. While ATDA sees, analyzes, and reports, humans' deliberate form committees apply for grants and write proposals. Meanwhile, these objects, potentially probes, continue their silent operations unimpeded by our sluggish response. This lag exposes a deeper, more philosophical unease. What if the universe has been broadcasting evidence of non-human intelligence for decades, centuries, or longer? But we've been blind because we relied on human perception. Now, with AI-driven observatories like ATDA, we're finally seeing differently, catching glimpses of what's been there all along. ATDA is just the beginning. More AI-driven observatories are under construction, and machine learning is infiltrating existing telescopes, from ground-based arrays to space-based instruments and radio telescope networks. Within a decade, most astronomical observations will be AI-mediated, with humans relegated to supervisors and interpreters, no longer the primary observers. This transition could reveal a cosmos far stranger, far more populated than we ever dared imagine, not because the universe has changed, but because we've finally learned to see it properly. This brings us to Atlas, the enigmatic object hurtling toward its perihelion in late November 2025. Its anomalies, sudden hydrogen cyanide emissions, and inexplicable anti-tail erratic brightness fluctuations are precisely the kind of signals ATDA would flag as highly anomalous, demanding immediate and intensive follow-up. A human astronomer might dismiss these as cometary quirks, natural phenomena dressed in unfamiliar guises. But an AI trained to detect deviations from expected behavior would rank Atlas as a top priority target, its every move scrutinized for signs of artificiality. Had ATDA been operational when Atlas was still faint and dormant, far from the sun, would it have detected subtle trajectory shifts or spectral oddities invisible to human analysis? We'll never know, as ATDA came online after Atlas had already captured the world's attention. But future Atlas-like objects won't slip through unnoticed. The AI is watching, learning, refining its detection algorithms with every anomaly it encounters. This era of machine-mediated transparency heralds a new reality. Nothing in the solar system will remain hidden for long. Every object, every motion, every emission will be cataloged, analyzed, and explained or flagged as inexplicable. But transparency cuts both ways. ATDA's data, funded by a consortium of universities and government agencies, is technically public, but it's subject to delays for peer review, national security consultations, or international coordination. If ATDA detects something truly paradigm-shifting, confirmation that Atlas is artificial or evidence of other probes, will that data reach the public immediately? Or will it be classified, funneled through intelligence agencies, and released only when authorities deem the world ready? The AI doesn't decide. Humans do. And history, from Psyche's blackout to ESA's data delays, shows that humans control information tightly when fear takes hold, wary of how the public might react to cosmic truths. Here we stand in October 2025, watching Atlas approach its closest point to the sun. its solar power piquing its purpose, whatever it may be, drawing ever closer to revelation. AI systems like ATDA scan the skies with a precision beyond human perception, while governments and space agencies guard data we may never see. The context is no longer purely astronomical. It's technological, political, existential. Fusion startups falter, black holes drift unseen through the galaxy, and quantum time crystals emerge in laboratories blurring the line between science fiction and reality. Atlas is the focal point, a cosmic enigma that weaves these threads into a single accelerating narrative. The silence from authorities is deafening. Their careful management of information, their performance of calm control, betrays their confusion and fear. Atlas is real, its trajectory calculable, its emissions measurable, its behavior observable. Yet its true nature remains shrouded in ambiguity, a deliberate uncertainty that torments us. As perihelion looms mere weeks away, the hydrogen cyanide cloud expands, and AI observatories stand vigilant, their unblinking gaze fixed on the skies. In classified briefing rooms and emergency planning sessions, decisions are being made about responses, warnings, or silence that will shape the future of humanity. We've pulled back the veil on Atlas, exposed its anomalies, connected the dots, and asked the questions that demand answers. But the cosmos offers no reset button. Once the pattern emerges, there's no unseeing it, no pretending the universe is as simple as we once believed. So watch the skies, not just with your eyes, but with the awareness that what you see may mask what's truly there. Watch for the subtle shifts in official narratives, the moment skeptics turn believers, the sudden classification of data that should be public. Watch for the signs of preparations behind closed doors for scenarios too sensitive to discuss openly. Watch Atlas as it moves inward, as it brightens or dims, as it behaves predictably, or defies every expectation. Is it the comet we hoped for, or the harbinger we feared? The universe is vast, ancient, and brimming with mysteries we've only begun to glimpse. Atlas may be just the first detected, only because our technology finally caught up. How many others are out there dormant, waiting, watching? How long have they been here? And what happens when they awaken? These questions haunt me, keeping me awake at night, staring into the dark, wondering if tomorrow is the day the universe changes forever. The evidence is clear, the timeline set the threat undeniable. And the silence from those who know the most, it's the loudest warning of all. As Atlas nears perihelion, as the AI observers accumulate data, as the anomalies pile up, we stand on the brink of a revelation that could redefine humanity's place in the cosmos. The question isn't whether Atlas is artificial. The question is what happens when we can no longer deny it.